Welcome. So in this video, we'll be answering this question before us. It says the graph illustrated below shows the recorded population of koalas K in a wildlife reserve at the end of each year T since the park's creation in 2002. So as you can see here, this is what our graph looks like. K is my vertical axis, is the population of the koalas, and T is my horizontal axis. It is the time in years starting from 2002. And this is the population of koalas right here. The first thing we need to do is in part A, in what year were koalas first recorded in the reserve? So that means what we're going to have to do here is we're going to have to figure out in what year were koalas first recorded. Well, as you can see here, I have the point 24, which means this right here is going to be 2. So it's going to be when T is equal to 2. Now here's the important part, here's the really important part. We know that when T is equal to 0, it's 2002, because that's when we're told that they started to first record since the park's creation in 2002. So that means if it's T is equal to 2, I'm going to take 2002, I'm going to plus 2 to it, my answer is going to be 2004. So my answer is going to be 2004 because when T is equal to 2, it's 2004. So the really important thing here, and what people make mistakes in, is they just leave their answer as T is equal to 2, and they're not reading the question. It says, in what year were the koalas first recorded in the reserve? Next, in the model above, if the model above is written in the form this, what is the value of A, B, and C? Okay, so if you look at this for a moment, what can you immediately tell? Well, we're dealing with a quadratic, and also we can write it in turning point form. So if I was just to come over here for a moment and just rewrite what we've been given, K is equal to A, T plus B squared plus C. Well, immediately, as I come up here to my graph, I know that this is a quadratic, which means this is going to be my turning point. So 2, 4 is my turning point. So I can come here and I know that my turning point is going to be 2, 4. So that means I can rewrite this thing like this. So immediately I know that B is going to be equal to -2 and C is going to be equal to 4. So remember, when I'm moving something 2 to the right, it's -2. And if I'm going 4 up, whoops, I should have put a 4 there. I go plus 4 to the end there. Okay, now I need to figure out what A is. How am I going to figure out what A is? Well, to figure out what A is, I'm going to utilize the other point I've been given. So I've been given 4, 12. So I'm going to sub in 4, 12 to find A. And we're going to use our trusty CAS calculator at this point. So let's do that. So let's come over here. Let's come here and let's go K of T control this. So I'm defining what it is. It's going to be A multiplied by T minus 2 squared plus 4. That looks good. So now it's defined. And now I'm going to sub in my point 412. So I'm subbing in the point 412 now, and I'm going to solve it for A. So because I've defined this, it's going to be very easy. I'm going to go menu, I'm going to go algebra, I'm going to go solve, and I'm going to sub in the point 4 into my T spot, so K of 4, and I know that's going to be equal to 12, and I'm solving it for A, so comma A. My answer is going to be 2. So that means my final thing here is going to be K is equal to 2 T minus 2 squared plus 4. And I would come up here, and I would say A is going to be equal to 2. And I'm going to put a box around my answer there. Perfect. Let's keep on moving. Next, it says, and let me get my highlighter out. I'm very big on using highlighters. Data is collected until the end of 2012. What is the population at this point? Okay, so again, let's remind ourselves that when T is equal to 0, that's 2002, so it's when I started. So therefore, if I'm at 2012 now, what is T going to be equal to? Well, I'm 10 years ahead, so T is going to be 10. So that means I'm going to put 10 into my function and see what I get out. So I come to my CAS again, and I'm going to be putting in 10. So I'm going to go K of 10. Whoops. And as you can see, it freaks out a little bit because it doesn't know what A is. Because look up here. Up here we have defined our function as being A is a variable. It doesn't know what it is. Just because we've solved it down here, it still defined it as it doesn't know. So that means there's a couple ways you could go about this. You could come up here and say, hey, we know that A is 2. And look at that. So we'll put those in such that A is 2 and we get 132 out. So that's going to be our answer. But if you wanted to make sure that, we defined it correctly, what you'd have to do is this. You would have to, there's a couple of different ways you could do this. You could go menu, you could go actions, you could go define, and then you could just come up here, hit enter again, and now it's defined A as being equal to 2. So that means when I go K of 10, it just gives me 132 straight out now, because now it knows A is equal to 2. Perfect. Let me get my highlighter. I'm big on the highlighter. In what year does the population reach 36 koalas? Okay, so what are we going to do here? So up here, this was koalas. So this time what I'm going to go is I'm going to go K of T is equal to 36, and I'm going to solve for T. So again, using my trusty CAS calculator, I'm going to go menu, algebra, solve. K of T is equal to 36. Solve it for T. I get two answers out here. One is a negative, so it's obviously wrong, and it's going to be like the other branch of my quadratic, but we only care about the positive one, so T is going to be equal to 6. Now, this is really going to test your ability to read the question. It says in what year? In what year? It doesn't want T is equal to 6. What it wants you to say is 2002 plus 6 is 2008. So 2008 is your answer, not T is equal to 6. You need to make sure that you're reading the question carefully. And then we put a box around this one as well. Perfect. Next, it says, what is the feasible range and domain of this function? Okay, so let's come up here, zoom out. We have to write down what the feasible domain and range is. Well, my domain is going to be all my t values. So t is an element of, well, I start at 2 and I include it, and this could, go on for forever. It could just keep on going on. I know that it looks like there's a point there, but that should be like that. It could just keep on going on. And then my range would be k is an element of, well, this is 4. So it's going to be 4 to infinity. And those would be my answers. Let's take these. Perfect. Next, let's come here. Let's grab out my trusty highlighter. A virus is known to kill koalas at a rate that is inverse of the population function. Find the function that describes the number of koalas killed per year. Okay, things got a lot darker than I expected. So let us grab our pen, and what we're going to be doing here is we're going to be finding our inverse function of what we've been given. So in other words, we're starting with this, k is equal to, now it's 2t minus 2 squared plus 4, and we're going to be finding the inverse of that. So that means we're going to interchange or swap k and t. So that means I'm going to get t is equal to 2k minus 2 squared plus 4. Now I'm going to solve it for y, so it's going to be t minus 4 over 2 is equal to k minus 2 squared plus or minus the square root of t minus 4 over 2 equals k minus 2. Now I'm going to plus 2 to both sides, so I'm going to end up with 2 plus or minus the square root of t minus 4 over 2 is equal to k. Now I'm just going to rewrite this. So I've got k over here. K is equal to 2 plus or minus the square root of t minus 4 over 2. Now we have to figure out whether or not it's going to be plus or minus. 9 out of 10 people get this type of question wrong because they leave it as, plus or minus. You have to choose which one it's going to be. There are a couple different ways you can figure it out. One way is by looking at your domain and range and realizing that they're going to swap. So my range is going to become my domain, and my domain is going to become my range. Now, when figuring out which of these we're going to choose, what you would do is you take your domain and you would look at it and you say, hey, my domain is going to be now my range. So my range is going to be 2 to infinity, and my domain is going to become, let me do this the other way. Might be confusing, sorry. So all I'm going to do is I'm going to swap my domain and range. So my domain is now going to be my range, 4 to infinity. And my range is now going to be my domain, which is 2 to infinity. So very simple, you're just swapping them around. And now, when figuring out whether it's going to be plus or minus, it's just a matter of looking at your range. So let me highlight that. And you see how my range is 2 to infinity? It's the positive side of it, of my square root function. So that means it's going to be the positive one. So it's going to be k is equal to 2 plus the square root of t minus 4 plus 2. You can see this because it's the positive side of it. I'm not going down, I'm going up. So by considering the fact that your domain and range swap, you look at your range and that's how you can figure it out. If you wanted to, you could think about this visually as well. If I was to come up here, I know that my inverse is simply going to be reflected. Oh, that is bad. It's simply going to be reflected across y is equal to x, right? So that means it's going to look something like this. You can clearly see that this is the positive side of a square root function. So that's why we took the positive of it. Remember your x and y swap. So this is going to become 4, 2. And this is going to become 12, 4. So we just swap those around. Perfect. So that's our answer there. So let's just circle it or put a box around it. Perfect. It says sketch this function on the same axis as the population on the previous page. We've done that. We did that right there, just then. Okay. And then the last question here. Let's get out a highlighter. It says the virus is identified as a more aggressive strain where the numbers of koalas killed every year is tripled. What would the new function be? Well, in order to answer this, what we're going to realize is that if it's going to triple, that's the same as dilating it from the x-axis by a factor of 3. So all we're going to be doing here is dilate from the x-axis by factor of 3. So we're going to take this right here. Let me just zoom out a bit. We're going to take this, k is equal to 2 plus the square root of t minus 4 over 2. And what we're going to do to it is we're going to times the whole thing by 3. So that means my final answer is going to be k is equal to 6 plus 3, the square root of t minus 4 over 2. So it's important here that you realize that this 3 is multiplied by the whole thing. So you just got to remember that brackets. So that means, oops, this right here is going to be my answer. So we started with our original, we multiplied the outside by 3 here, and then we got this as our answer. Okay, that is everything. Hopefully you found this useful and going through it. Hopefully you appreciate the importance of using your CAS efficiently And yeah, that's all I've left to say. Hopefully you found this useful, and I'll see you in the next one.